I guess we can begin. Thank you so much for coming to this session. My name is Alina. I'm happy to see you all. And this is actually my first time at JSpring. I've been to NLJAG events many times, but this is the first time at JSpring, so I'm very happy to be here. And in this session, we will talk about GraalVM and Spring Boot and how they come together so you can build even better, faster, more lightweight applications. Let's go, and let's start with a quick intro. So this is my name and my handle on all kinds of social media. If you want to follow up, ask a question, ask for demos, etc., you can find me by this handle. And I'm a developer advocate for GraalVM at Oracle, and more specifically, I work at Oracle Labs, which is this very cool R&D unit at Oracle, where we're doing a lot of research and bleeding-edge new projects. GraalVM has been such a research project for over 10 years at Oracle Labs, and now we are happy that it's generally available and you can use it for your production applications. I love open source and communities. That's why I love coming to places like this, where I get to talk to people in person. I love both programming and natural languages, and I'm also a cat and dog person. And for that, I actually brought the receipts. So this is my cat. Please meet her. I love her very much, and I want to make a case for adoption. So if you want to have a pet, consider adopting rather than buying. She's been adopted like 11 years ago, and I've been very happy ever since. So I hope if you decide to get a pet, you can also adopt one from a shelter. OK, and now let's talk about GraalVM and the things that you need to know to build your Java applications with GraalVM. So the first thing to know about GraalVM is that it is a JDK, and sometimes people are confused about this because we are doing a lot of, maybe less usual stuff for the JVM, but it's also a JDK, so you can run your applications on GraalVM as you would on any other JDK of your choice, whether that is Oracle JDK, OpenJDK, etc. And we are really not taking anything away from the JDK. We are just adding things on top. For example, we have added our own JIT compiler, Graal compiler, which is itself written in Java. So we love Java so much that we even wrote our own compiler in Java. That is one thing that we have added to the JDK, but more interesting and more relevant to the session today, we also have added this native image ahead of time compilation tool to the JDK, where you can take your Java application and compile it ahead of time into a native executable, which you can then run without a JVM and on a machine that doesn't even have a JVM on it. So really, GraalVM gives you this choice. It's not all a native image. You can run your applications on GraalVM as a JVM, and then you can maybe get 10, 15% performance improvement just because the compiler is so good. Or you can go ahead and compile application ahead of time with native image. So really, with GraalVM, you get this choice of how you want to run your application. And I also like to show the slides every time I'm at a conference and somebody asks me this kind of tricky question. So when should I not use GraalVM? And my answer is always use GraalVM, but decide for yourself which part of GraalVM is better for you. So if you want to stay in the JVM world, you can just use it as your JDK, or you can go ahead with native image. And I said we have been working on GraalVM for a while, and that's why I love showing this slide of history and some important milestones in the GraalVM history. And I love showing the slides because, A, I think it's a beautiful slide design, so I'm just very proud of my team design skills. But also, there are some important milestones here. So a few things that I want to specifically highlight is that in 2019, we went GA after all the release candidate builds that we have been releasing. We finally went GA. And then in 2020, so 4 years ago now, Alibaba already adopted GraalVM and native image specifically, and we're deploying production applications on native image. So it might seem like GraalVM is this, crazy, new, revolutionary, kind of scary technology, and I can totally see that. But also, there are people who have been deploying native image on a huge scale. Alibaba, you can imagine the traffic that they have, and they've been very happy ever since. And getting closer to the topic of the session today, so in 2021, along with the Spring team, we released this Spring native project. So you could have built Spring applications with GraalVM since 2021. But then in 2022, it finally became available GA in Spring Boot release 3.0. So now it's even easier than ever to build applications with GraalVM and Spring Boot. So let's talk about native image and this ahead-of-time compilation part of GraalVM and how it's even possible to take something as dynamic and complex as a Java application and compile it ahead of time. So the way this works is that when you run our native image utility and you give it your application, and as an input, it takes bytecode, so it has to be a jar or class files. So you run the native image command, and then it will start exploring your application to try and make sense out of it and understand everything that your application is supposed to be doing. So it will do so starting from the main entry point, and then it will try to find all the code that we call reachable. So the code that your application is actually actively using and that is involved in what your application is supposed to be doing. So it will try to discover all of that code and put only that code in that produced final native executable. And this applies to the code that you wrote, so what we call user code, but the same applies even to your dependencies at the JDK classes you are using. So it will analyze your entire project, and that it will only put the things you are using into this native executable. So that is one part of the story, and there is another part that is sometimes underestimated, but along with this, we will also perform a heap snapshotting. So we will look at your heap, and we will analyze which objects are safe to initialize at build time, initialize them, so you can start with a pre-populated version of heap. And then as an output of this whole process, you have a native executable that can start much faster because it doesn't need to do all those things that the JVM normally does at runtime, and we are shifting this work to build time, basically. So you know when you start your application on the JVM, it needs to load classes, profile, interpret, compile, and then eventually it warms up and can run really fast. So we offer a trade-off where you can shift all that work to build time, do it once, and then every time you start your application, you can start much faster. And as an output, you have native executable that is platform and operating system specific. But enough talking, let's see how it works in action. So the first thing that I want to start with is this, what's going on? OK, connection issues, give me 1 sec. Where is my hotspot? Apologies, this was not planned, but at least you can tell that this is definitely a live demo, and this has not been pre-recorded. Let me just recreate my hotspot. I was about to make a joke that I wish everyone to have as much faith as I have in my little phone hotspot. Let's see. Reconnect now. Why not? No, please stop. OK, retry. Yes, I think we are on. Let me go here. Phew. OK, phone hotspot justify itself. So we were looking at a plain Spring application. Here's my main class. And I also have this one controller here that exposes an endpoint, this one. So we are just getting this message from our endpoint. So let's check our Java version first. Let's do Java version. And I'm on GraalVM version 23. So as you know, Java 23 will be released in September, and GraalVM for JDK 23 will be released in September on the same day. But you can already give it a try through our early access builds. If you want to be on the bleeding edge and try things that have not been released yet, you can do so, and you can even very easily install it with SDK man. That's what I did. So we are on GraalVM for JDK 23. So let's go ahead and run our application. I promise that GraalVM is a normal JDK, and it can do all the things that a JDK can, right? So let's run this app on the JVM first. It starts, and it starts in something like 1.2 seconds. You also could have noticed that this is a cloud instance, so this is not being interfered with by my slides or anything at all. It's a fairly isolated environment. So if we go back here and we go to our hello endpoint, as expected, we can see our hello message. But where is the fun in that? Let's go ahead and try compile it to native. For that, let me do maven p native. I have a bunch of profiles, but for this demo, I will just use a plain native image native profile. And let's go ahead and compile this. So a few interesting things here. We see that here we have somewhere process AOT step from Spring Boot. Where is it? Process AOT. OK, it is somewhere there, and that is the AOT transformations that Spring Boot does to my application. It's just hard to catch it with a lot of output. And then the next interesting thing that happens is that now native image kicked in, and now it's building my application ahead of time. And this is a step where sometimes people, especially when they're building a larger application, they kind of start losing patience here, and they complain to me, Alina, this is taking so long. I don't have this kind of patience. Why does it have to be this long? Like, can you do something about it? We are doing something about it. It will be in the end of the session. But also I want to point out that even for my fairly trivial application, so you can see it's maybe, what, 5 classes and a few dependencies from the Spring Boot, Spring Web, JDK, etc. So even for that application, what Native Image discovered is that even this app has almost 17K reachable types. And types, those are classes, primitives, arrays, etc. And then 25, almost 26K reachable fields, and almost 90K reachable methods. And that is only the ones that my application is actually using. And in fact, there is way more stuff in our application. So it is not trivial. It takes a while to build this whole universe of your project and understand what it's supposed to be doing, because for a Java project, along with the dependencies, there are a lot of things going on. That's why a build can take some time, because ahead of time, we need to build a whole universe of your application and discover what it's supposed to be doing. So it does take a while, but it was not that bad while I was chit-chatting. In the meantime, our build has been completed in 46 seconds. So I would say this is not too bad. And then if we look at the outcome of what happened there, target, we see that our application is freshly recompiled, and the size is 62 megabytes. So let's go ahead and run it, target demo. And now, if you remember, the previous version started in a little over 1 second. This one starts in just 49 milliseconds. And if we go back here, it does the exact same thing. So it is fully available, but starts much faster. And I want to do one more thing here. So we will do proper benchmarking later on, but I want to do a trivial benchmarking on the case of this app. So let's do this, user bin time -v. Let's start, and now we are also timing our application. And if you go back here and send some load to the app to try and emulate maybe a little web server that is serving our user request, when we will kill the app, we will see some performance statistics of how our app performs under this, let's say, minimal load. So as I was speaking, I have sent, let's say, I don't know, 25, 30 requests to the app. So let's finish this now, and let's go ahead and let's kill the app. And now we see there's a little report. There is a bunch of things there, but one thing that I want to emphasize specifically is the memory usage. And here it's at 69.5-ish megabytes of RAM that our application is using at runtime. And I think this is pretty cool for a web application that is available, can serve our request, and is fully ready to go. And notice how I did not even limit memory in any way. So if I wanted to, I could run this app and pass my XMX settings and limit the memory. But even having all the memory on the machine available, it's only taking 70 megabytes, and it's not using that much memory anymore, because unlike the JVM, it doesn't need to recompile and discover your whole application at runtime. So this is pretty cool, but let's see what else we can do. OK, so we've seen the startup. And if you have heard one thing about GraalVM and native image, you probably have heard the applications with native image start very fast, much faster than on the JVM. There is no this warm-up curve. There is no warm-up time. And people sometimes say, OK, we can see how this is very good for cloud applications, microservices, serverless. But what if I have a longer running application and I don't care about startup that much? So maybe I deploy it, and then it runs for, I don't know, hours, days, weeks. So startup time is really not that relevant for me. And I agree with you that it could be the case, but luckily there are more things that native image can do for you and offer for you. So another thing is lower resources usage. And I have showed this on the example of our little web application and how little memory it uses. But it applies to all the same things. So memory is much lower, CPU usage is much lower, and even if you want to reduce electricity usage, it's also doing just less thing in runtime than the JVM would to execute the exact same code. And this is very good, I think, in pretty much all cases. So obviously in the cloud, where you're paying for the resources that you are using, this is good because you can get the same job done but using fewer resources. Or even if you're using your own infrastructure, you can also reduce this usage. And I like also how some other people talk about this aspect of lower memory usage. So the first time when Spring Native was presented. There was a session from Josh Long and James Ward, and they showed pretty much a similar application. And they also measured the memory, and they said, hey, so this application runs, and it uses maybe 100 megabytes of RAM in their case. And they said how often it is that you're running your application on Java, and you're giving it 1 gig of memory, let's say. And obviously, many people in the room raised their hands. So they said, imagine that for the footprint of that application, you can deploy 10 such native applications, or maybe you can deploy 1, but cut your memory usage by 90%. So I think this is pretty useful. And another interesting aspect of native image is predictable performance. So it starts fast, as we will see also later on in the presentation, but also its performance is very predictable and very stable over time. So let's say you have an application that needs to serve requests that are coming from your users, customers, and you want to make sure that it performs very predictable over time and very stable over time. That is another aspect that it can give for you. And another interesting part of native image is that it also improves security. So unlike executing your code on the JVM, it eliminates certain attack vectors because there is no JIT compilation anymore, and because also it reduces the attack surface of your application. And also, if you want to have smaller applications, so maybe you want to have smaller container images so you can deploy them faster or scale them faster, that is also something that native image can give for you. Now, when it comes to support from all the frameworks and cloud vendors, I think there is really no reason not to be building an app with GraalVM in 2024, because all the major Java frameworks and all the major cloud vendors have some kind of support for GraalVM native image, either as libraries or SDKs, so they give you those utilities out of the box to build apps with GraalVM. And with that being said, let's talk about Spring AOT and how Spring and GraalVM come together. So there is this interesting aspect of how Spring works, and that is when you first start your application, what happens is at runtime, Spring as a framework needs to discover your whole application, pull all the config from all the different places in one place, and then build this kind of universe and understanding of your application by stitching all those pieces together. So what's interesting, native image is doing pretty much the same thing. So it also needs to look at your app, analyze what it's doing, pull all the config, make sense out of it. But native image does those things normally at build time because we're trying to shift all that work to the build time. So you can see how there is a bit of like a gap here. So Spring normally would want to do those things at runtime, and we want to do them at build time. And for that, there was this new Spring AOT project introduced, which is a new module and a new step basically in the Spring build process, where when you run your application in the native image mode, you can also do on the JVM, but this specifically shines in the native image mode. So when you run your application, Spring will introduce the Spring AOT processing step, where it will transform your application in a way that is easier for native image to understand. This step also will make your application faster by itself, but also specifically, it's very friendly towards native image. And the way Spring AOT works is that, first of all, it will look at your config, and it will transform that config into more like functional style config that is easier for native image to understand. So for that, it will produce actual Java sources for your configuration files. It will also produce bytecode for things like proxies, and it will produce so-called hint files. So why all of this is necessary? It's because when we are building our application, that is happening ahead of time, so the runtime hasn't happened yet. And technically, there is no way of knowing exactly what will happen at runtime. So this ahead-of-time compilation needs to happen under a closed world assumption. So everything there is to know about your application, we need to know all of that at build time, so we can build an app aware of all the features that you might want to use at runtime. And there are those more dynamic Java features that pose a certain challenge for this ahead-of-time compilation, because if you want to do reflection at runtime, this will be a bit more challenging for native image. So how many of you have heard that GraalVM doesn't support reflection? Still, some people. GraalVM does support reflection, but there are things to know. So more predictable reflection calls, native image has this detection mechanism that it will detect them at build time, and it can even automatically build an app with those reflection calls in mind. But then if you're doing something more tricky in terms of reflection at runtime, or if your framework is doing those things, there needs to be a way to tell native image ahead of time that, hey, this will happen at runtime. Please make those things reflectively available as you're building the app, because this will be needed at runtime. And this applies to reflection, serialization, proxies, resources usage. So those things work, but there needs to be a way for you or the framework on the library to tell native image at build time, hey, those things will happen at runtime, please keep them in mind. And this is where Spring AOT comes to help figure out those things for you so you don't need to configure them manually. OK, let's go. And for that, I want to show you more demos of Spring AOT, Spring Boot, and GraalVM in action. Let's see. OK, and our hotspot is still on, so that's a good sign. OK, let's go. So the first thing I want to show you now is this native Spring Shell app, Spring Shell. So for the longest time, Josh and others were telling me that seems like GraalVM is a good tool for building CLI apps. And indeed, if you want to have your CLI app, most likely you want it to be compact and fast. And that's exactly something that native image gives you. And I've been told many times that Spring Shell works very well with native image, but I never give it a try until now. And now I did, and I want to show you what I have here. So this is my cute ls app. So this is like ls that lists your files but cute, because to be honest, normal ls is kind of boring. And this is implementing using Spring Shell, and I have already it compiled. So let's go ahead and run it. So let's clear this, target native Spring Shell, I believe. And it's on, and it comes with a bunch of pre-built things from Spring Shell itself. So for example, it has built-in like help, history, etc. commands. And there is my cute ls that I have implemented myself. So let's go ahead and run this. And I think we can agree that this is much more cute than normal ls. But also, it's quite fast, and that's exactly the experience that you want to have from a CLI app. And then it also comes, as I said, with other pre-built commands. So for example, we can retrieve history, and that is all coming from the Spring Shell module. So this is pretty cool, I think. But what about building something bigger? So let's say we want to do the fancy stuff, and we want to do AI, because no talk can happen today without any AI in it. So let's see how we can use Spring AI with GraalVM and what we can build with it. So for that, we have this another app that is a travel recommendation app, where we are showing a user a form, and we are taking their input for the destination that they want to travel to, and what kind of activity they want to do, and what is the mood that they are in. And then we will go and talk to the OpenAI API. And we are using the latest and greatest GPT-4o to get travel recommendations for our user. So let's do this. Target, and we already have it compiled, so we can get to the good part. And I want to emphasize here that my whole application, so all the classes, everything that it's using, it's 100 megabytes, 109. And if I want, I can compress it even further, but I think this is fairly good for a web application that it's doing some business logic. So let's go ahead and run it, travel app. And it starts fairly fast as well. And let's go here, 8080. OK. And I want to stop here for a second. Can we admire this beautiful UI that I have built myself from scratch in HTML? I know it doesn't look like a lot, but trust me, it looks much better than it did in the first iteration of this app. So let's say we want to travel to Switzerland, because that's where I live. Let's say we want to do hiking. I don't really want to, but you kind of have to if you live in Switzerland. And let's say we are feeling adventurous, and where would it send us? OK, so the recommendation is to go to the Lauterbrunnen Valley. I guess I cannot really read this even, but it says that it offers majestic alpine peaks and features numerous waterfalls. So I would say this sounds good. But just to make sure this is actually working, there is no pre-baked data. Let's say we want to travel to the Netherlands, and maybe we don't want to do hiking anymore. Maybe we want to do something else. So let's say we want to do cocktails, and let's say we are still feeling adventurous. So what would be the recommendation? And I have a feeling this will be Amsterdam, but it's freshly generated. So let's see. It is Amsterdam. So yeah. This is the app that we can build, and I think it gives us some good recommendations. And this is built using both Spring AI and GraalVM. And I want to emphasize here that I have not done any configuration. I did not do any reflection, etc. configuration myself. It all just worked out of the box. And most, if not all, of the Spring modules ever since the version 3.0 will work with native image out of the box. OK, so those were cool things that hopefully I convinced you can build with GraalVM. And now I want to show this kind of scary slide and talk with you about using libraries in the native image mode and configuring those more dynamic Java features and how you can make them work in native image. So again, the closed world assumption ahead of time compilation. So things like reflection, serialization will pose a certain challenge for native image. But there are many things that you can do about it. So what if you want to use some kind of library, or maybe the code that you yourself wrote, and that code is using reflection, serialization, and resources, what you can do. And each bullet point here is a way to make those libraries or features work with the native image, and that is going from the best case scenario to a scenario that requires a little bit more work from your side. So let's start here. It's a bit complicated, but if you want to use libraries, this is something I need to show you. So one way how libraries can work with GraalVM native image is that they can be out-of-the-box built in the native image-friendly way. And we see this more and more lately, where people design libraries to be native image compatible out of the box. And that is the best case scenario where you as a user don't need to worry about anything. Now, obviously, there are more libraries that have been out there before native image became so popular, so what to do about those? The next best option that can happen is when a library includes config for native image within the library itself. So again, this is something you don't have to configure. Native image will just know how it works. And to illustrate that point, I want to show this example of the H2 database and the source code that we can look at here. In the past, I used to show a demo where I would want to build an application with H2, and then I will struggle because it could not figure out how to do reflection. But now, if you will build such an application, it will just work, because here in the H2 source code itself, there is this reflect config JSON file, and it tells native image, please make those things reachable at runtime, because we need to use this in our library. So this is probably the second best option of how a library can be native image compatible. It's because it can ship a config within the library itself. But we understand that some libraries are still working on this, or maybe some still haven't even started working on this. So if your library does not ship config for GraalVM native image within the library itself, it seems like maybe there should be a place where we can reuse and share config for native image. And indeed, we have created such place. So this will be the next best thing that you can do. We have this repo on GitHub that we have created together with our partners from the frameworks and libraries. And this is a centralized place where users can contribute config for all the different popular libraries and tools. And then you can reuse this config to build application for native image, because it seems like if somebody already figured out config for let's say, I don't know, native, you don't have to be doing that yourself. You can just pull that config from that centralized place. And the best thing is that this is already integrated with our native build tools, so the Maven and Gradle plugins coming from the GraalVM team. So if you are building an application and you have our Maven and Gradle plugins, they will pull config for all the different things from here automatically. You don't even have to worry about it. So those were the best options, and this is also the happy path and most of the cases. So I hope if you build a new application now in 2024, you will be anywhere within those first 3 bullets, and things will just work for you. But I also want to tell you honestly what happens if your library does not support native image yet. What are the things that you can do? So the next bullet point here is, let's say you are on a version of a framework, Spring Boot, Micronaut, Quarkus, Halidon, that is working with GraalVM native image, and they have some kind of support in the framework. So what you can do, you can use whatever the framework support there is to create those hints for native image from the framework itself. To show you how it looks in action, here is my original native Spring Boot application. And let's say we want to do something like reflection at runtime. So let's say here is our reflection controller, and here it's done maybe in a slightly less obvious way to try and outsmart and confuse native image. So if I want to make this message field available at runtime, what I can do, I can create a config file myself. But if I don't want to, because it's not very exciting to be writing JSON files, I can use this feature from the Spring AOT, and I can programmatically register these hints for native image. And when I write this, what will happen, Spring Boot will generate this config for me and tell native image, hey, there is a config, please make this available. And this applies to reflection, but also if I want to read some resource, let's say at runtime, I can do a similar thing where I can register that I'm trying to read this message.xml file at runtime, and I can tell Spring, hey, can you please register this thing and make it available for native image at runtime? I know this looks maybe not very exciting to write and kind of scary, but hopefully this is something you don't have to do. That is only if you are writing a code yourself that looks like this, and you're using, like, let's say, some internal library that doesn't support native image. So this is a programmatic way to do it, which is maybe not so pretty, but again, this is for libraries and features that don't work with native image yet. And then let's say you are even on the older version of framework that doesn't support GraalVM and native image. So what you can do then? There is no framework support. So the next best thing you can do is use the tracing agent that we ship ourselves within the GraalVM and native image. And the way this works, you would run your application on the JVM with the agent attached to it, and you need to show us what the application is supposed to be doing. So you need to apply relevant workloads. Let's say I want to read that resources file, or I want to make that reflection call. So I will run my application on the JVM with the agent attached to it. I will emulate this production workload, and this agent will observe all those calls, and it will output this config for me automatically, or let's call it semi-automatically. So that is one more option. And then the last option is you can obviously also write a short config file to tell native image, hey, I'm trying to do this and that through reflection. Can you please make this available? But hopefully this is somewhere you will never have to get to, and you will stay within this happy path when the config is happening from the library or from the framework automatically. Let's talk about performance. I really appreciated that this morning we had a performance keynote, and I want to add to it from the compiler side of things. So I talked a lot about the ahead-of-time compilation and how it compares to the JVM. So what do you think? Can we run applications faster or as fast on AOT as we would on the JVM? So who thinks it can be faster on AOT? OK, some people who probably have tried GraalVM. I'm happy to see this, because normally when you talk to Java folks, the general sentiment is nothing can beat the JVM. JVM is absolutely amazing. You, with your AOT code, cannot even compare to the JVM. It's very hard to beat the JVM. I know it is, but I'm sure there are a bunch of things we can do for it. For that, I want to start again with a demo, and then I will show you what exactly was happening there in terms of performance optimizations. So for that, I will demo a Spring path cleaning application, and I think we all know what it is. So it's a web application that is commonly used for benchmarking, where you can read data, write data, create owners, create paths, create visits. So it's a common standard for benchmarking, at least in the Spring community, of what you could possibly be running in your production environment. So let's go ahead and benchmark it. And for this, I'm very proud of this benchmarking setup that I have brought. This is still not entirely scientific, but this is almost as scientific as you can get in a format of a conference session. So we will benchmark a bunch of things. First, we will start with benchmarking on C2, which is the default compiler in Oracle JDK, OpenJDK. So you can think of this as your OpenJDK kind of environment. And what we will do, we will run our application. Here, I'm just running on GraalVM and turning off the Graal compiler. So effectively, this is C2. And then we will send a bunch of requests to the app. We will see in a second what are the requests. And the setup is that we will start our application, and we will wait for 10 seconds just for the JVM to start. Then we will do a warming up run, and then we will do the actual benchmarking run. And the request will be also diverse. So it's not like we will be starting our application and just bombing one endpoint with a million requests. No, we will try to emulate user behavior. So we will send requests to create owner, create path, create visits, read data from the database. So almost as scientific as you can get in a conference talk kind of environment. So let's go ahead and benchmarking. And this will be, we are in the wrong folder. AOT performance, yeah. OK, so let's benchmark on the JVM, bench jet C2. So this will now start our application on the JVM, and before even warming up, we will wait for 10 seconds for the JVM to start, because we have run this before, and we have noticed that on average, it takes on this machine maybe 5 seconds for the JVM to start. So you are trying not to abuse it and give it a chance to properly start and then warm up. So now it is warming up, and we see that in our warming up round, we have about 471 requests per second. Maybe it's fast, maybe it's not, but we all know that JVM warms up, so we hopefully will see better numbers when it is warmed up. So let's give it a few more seconds to finish the actual benchmarking run. And now we get 1.3K requests per second. So we see that indeed it did warm up over time. So my benchmarking setup seems legit to me because it did improve over time. But let's see how native image compares to this. And for that, let me do this. So I will start it, and then I will say what it does. I think it's, yeah. So now we will do the exact same thing. We will benchmark it as a native image application, and we will also wait for 10 seconds, and then we will warm up, and then we will benchmark, which is kind of funny, because here it seems like nothing was happening because we started our application, but we had to wait 10 seconds because we were waiting for the JVM for 10 seconds, and we want to have like apples-to-apples comparison. So here it was kind of funny because it seemed like nothing was going on over here, but it was just waiting as we were waiting for the JVM to start. So now it is running, and we see that even in the warm-up run, it's already twice as fast as the JVM, because I've been saying that it doesn't need to warm up because it doesn't need to compile code, profile code, etc. And now that the warm-up is done, we see that our requests per second here are 1.1K versus 1.3 on the JVM. I personally would say that this is still good and this is still on par because JVM is amazing and it's very hard to beat the JVM at its own game. But I want to give it one more try. And for that, I have yet another version of this app that is compiled using a few additional optimizations. And here we will see how native image can perform if we give it extra optimizations and whether or not it can compare better with the JVM. So again, the same setup. We are starting for 10 seconds, then we are warming up, and then we will do our benchmarking run for another 20 seconds. So let's see. Now the warm-up run is done, and now we are doing the actual benchmarking run. OK, it should be done in a few seconds now, and it is. And now this one is at 1.7K requests per second, so even slightly faster than the JVM, also even slightly better than I would expect. So yes, if you know what you're doing, you can get good performance on the native image versus the JVM. And I also want to show you how we are doing in terms of resources usage. There are a few interesting charts to look at. So as I was running each of those benchmarking rounds, I was also observing the resources consumption of each of the application. And this is our JVM run. This is our plain native image run. And this is our native image optimized. And let's compare them side by side. So the way to read this is the blue horizontal line, that is memory usage, and then the vertical red lines, that is CPU usage. And you can see that the JVM is consuming quite a bit of CPU as it starts, as I was saying, for about 5 seconds, but also as it performs. And then for native image, this is much more stable because we don't need that much CPU anymore because we're not compiling code at runtime anymore. And in terms of memory, native image is also much lower. But you can see that here in the middle section, the one that was like fast but not as fast, we are using less memory. But then in the last version that is also more performant, we are using more memory. So what was happening there, and what is that magic that I did to make it go as fast? So if you want to have fast applications on native image, there are a few things that you can do. One is called profile guide optimizations, and this is an optimization where you can build an instrumented version of your app and then run it and apply relevant workloads and record the profiles into a file. So kind of like what JVM does at runtime, you can do the same with native image, and then you can build application ahead of time, but being aware of what it will be doing at runtime. And this way, you can combine ahead-of-time optimizations with the profile information that normally JVM does at runtime. And this is the most powerful optimization that you can do with native image. Now, the next thing, if you don't want to be doing this, because this is like a two-step process where you're building an instrumented binary and then you're building a fully optimized binary, it seems like predicting application profile is a good task for machine learning. And indeed, it is. So if you don't want to be doing this first thing, which is the best, but maybe you don't have the time, you can build out-of-the-box application with MLPGO. And there we will try and predict the application profile of your application. And this one will give you 6–8% performance improvement out of the box. So not as good as the first one, but still better comparing to not having any profiles at all. And one more thing, there could be different GC strategies, as Garrett said before. But if you want to have good peak throughput on native image, G1 GC is usually your best bet. And then a smaller one, but there is one more extra thing that you can do, and that is called a Mark Native, and that is leveraging the specific hardware features of the machine that you will plan to deploy your application to. So if I know that, let's say, I'm building my application on this machine, and it will only run on this machine, I'm not planning to share this executable with my users, customers, etc., I can say, hey, please specialize for this machine, because this is where it will run, and it will leverage all the best features of my machine specifically. And yes, I did measurements by myself, but also we have more measurements where we can see how native image can be on par with JVM and specific things that you can do. And even when it comes to using memory efficiently, native image can give you very good memory efficiency because it gives you compatible peak throughput, but uses much less memory. And I want to give you a few good practices to build the applications with GraalVM. So I mentioned that we are building applications that are platform and operating system specific. So you cannot build, let's say, on a MacBook for a Linux machine. But there are things that you can do. For example, you can use our GitHub action and build there for all the possible platforms that you might need. And that is something that I would recommend to you if you want to have cross-platform builds. It's not available out of the box, unfortunately, because we need some JDK-specific classes for each platform. But you can use CI/CD platforms, and that is something that I can recommend for you. And then again, for Spring projects specifically, if you want to build applications with GraalVM, now we also have our own build pack. So it's even easier for you to build applications with GraalVM and Spring Boot. Now, a few words about the reduced attack surface. So I mentioned the GraalVM and native image specifically reduces the attack surface of your application because we are eliminating the code that you are not using. So we will just throw all of that away. But also things like JIT compiler attack surface is just not possible in native image because there is no JIT compiler anymore. It's all machine code that is already ahead of time compiled. And if you want to take maybe like one photo of one of the slides, I would recommend you taking this one. That is if you want to move your existing application to GraalVM native image, or if you want to start a new project, those are a few things that I'd recommend for you. The number one thing that you can do is to add our native build tools. That is the Maven and Gradle plugins from our team. And those will help you build applications, test your applications, and pull config for all those libraries into your project. So that is my overall recommendation for all projects moving to native image. And I want to talk with you about what is next. So recently we released our GraalVM for JDK 22, and then in autumn we will have GraalVM for JDK 23. Here I usually also show a demo that I have borrowed from Nikolai Parlog about using later Java features, and I have ported it to GraalVM native image. But I know that Nikolai has a session later today, so I will not spoil for you his demo. Just know that what he will show also works as a charm in GraalVM and native image with all the cool features such as virtual threads. And a few cool things that we are working on. So what I said about GraalVM and native image and build times, we are working on this new project where we want to give you a way to build what we call extension or base images, where let's say I have my Spring Boot project, and I can define what is my application code, so the code that I wrote myself, and then the rest can be just base images. So let's say my Spring Web, Spring Data, Spring Core can be those pre-compiled, kind of like shared libraries images. And then every time I'm introducing changes to my code, I only recompile my user code, and the rest stays compiled. And that's why we believe we can take build times down to just a matter of a few seconds, because you will only recompile this thin layer that you wrote yourself. So this will be pretty cool. And another aspect is that you can also be able to share your resources in the cloud. So let's say you deploy your application, again, it's a Spring application, and you have your JDK base layer and your Spring layer that you can share between all the instances, and this way you will consume even less resources with GraalVM. And another big project that we are working on is called GraalOS. I really like the name. It's like an operating system built on Graal. And that will be basically a deployment platform where you're deploying your application as a native image, and then we will take care of the scalability, resources sharing, etc. for you. You don't even have to do containers. You can just deploy as a unit your native image application. So with that, I want to wrap up, and I think I'm almost out of time. So hopefully I convinced you to at least try GraalVM if you want to have fast startup, lower resources usage, good performance, and even improved security is a very good recipe for that. To get started with GraalVM, you can go to our website. You can pull our container images, and if you're using SDK Man as you should, you can very easily pull GraalVM from SDK Man as well. And I want to make a quick ad. So apparently at 4:15 p.m. today, there will be 2 more GraalVM sessions. So Sandra will be talking about monitoring native image applications. And Berjan, who you all know and love, will be talking about Quarkus and GraalVM. So I recommend you going to both of those sessions. But there is, like, if I'm being honest, there is another good session. So it's not about GraalVM, but Alex will be doing an amazing session on vector databases. It's not about GraalVM, but it is very good and very fun and very entertaining. So at 4:15 p.m., we will all have a very tough choice to make. With that, if you want to ask me a question, I will be here down the stage, but also you can ping me on Twitter. And if you want to have the demos that I have shown today, you can just go to my GitHub page, and there are all the repos that I have shoved. And with that, thank you so much. Please rate this session. Many thanks, dankjewel, and I'm ready for your questions. Thank you.